So back again, I'm just going to make sure that the main is set to override. I'll disable the override camera resolution. And on the redshift, I'm going to put this back to 256. Maybe even go lower. I'll go with 128 to see if I can render this much faster. I want to render the whole frame range. And this one is definitely ready to go. Regarding the sparks, I'm just going to make it a similar test. I'm going to be rendering this with the motion blur anyway. So here it's going to tell me that it's not going to be calculating the motion blur for the sparks because of the change of the topology along through the animation. So we can't really compare the previous frame with the current frame to interpolate the motion blur properly because the number of points and vertices is changing from frame to frame. But it should calculate the motion blur for our robot, and that's something important because when we composite one thing on top of the other, we really want them to match. So let's make sure that this is also set to 0.4. On the sampling, I'm going to lower these to the standard values, just maybe increasing this to 64. Global, here on the globals, the reflection, I'm going to bring this down to 2 as well. One thing I didn't turn on was the global illumination. That might help as well. So I'll keep global illumination here, and I'll have to do another test there. On the sparks, I'll probably skip the global illumination. Well, let's give it a try with global illumination. We have motion blur. Main, let's not override the resolution and render the whole resolution. Yeah, let's give this a try. Render view, hit render. So it seems like this noise will probably be coming from the global illumination. If we check the diffuse sparks, it's already kind of noisy. Diffuse, because we only have sparks, it's going to be the same. So it seems already pretty noisy. So let's try to denoise this a bit. Let's see if we can actually make use of the denoiser. Okay, so the denoiser is actually doing a pretty great job on this one. So I'm gonna, because this is a technical pass, this is just gonna be added to on top of what we already have. This should be fine to apply some denoiser on this. So it should save us some a good amount of render time, and it's a much cleaner solution than what we had before. So all you have to do is go to your render, and on the sampling section, you just go down to the denoising and turn on the optics denoiser. Okay. So this one is also ready to go. I'm going to change this to frame range. The robot, it's all ready to frame range. Let's have a look at the blast. So same thing, just going to go here to the sampling, lowering this to 0.01, maximum samples to 64. Global illumination on this one is definitely not needed because most of the light is going to be coming. This is pretty much just another technical pass where we have the particles being self-luminant, so the lights won't have pretty much any effect at all. I'm going to just put here the dome for the sake of having something in there, but it's not going to do much. Everything else should be okay. We won't be calculating any reflections or anything like that. So I'm going to turn this off and let's give this a try. Okay, so this is what we currently have. This should be good enough. It's currently a little over 2 minutes, but it should work pretty well when we composite this over the other layers. Here I'm gonna leave this one, which is again, just make sure that Redshift doesn't create a default light that's gonna look like a flash. And this should be ready to go as well. I'm gonna change this to render frame range. We have the technical blast reflection, and in here I'm gonna switch this. I'm not gonna spend too much time on this one. This was rendering pretty fast, so I'm gonna go to redshift, and on the sampling here, just lowering these to standard values. This should be okay. Let's just do one test and see how it looks. So as you can see, it's rendering over under 30 seconds, pretty fast. It's going to be underneath a bunch of stuff. We're mostly just interested on this pass, so it's totally fine as is. So this one is also ready to go. I'm going to switch this to render frame range. And we have everything. Now I'm going to create copies of these for the different cameras, and then I can submit everything to render. You can kind of do something like this. I'm gonna put these like this, and you can just connect them like this so they're rendering in sequence. Just go to the last one, hit render to disk, and they're going to be rendering all together or sequentially. If you want to control how they render, you can come here and this node and all inputs frame by frame, or you can choose node by node. That's also an option that you have. So yeah, I think we're finally done with this. As I said, I'm going to create these the copies of these for all the cameras. So pretty much just grabbing these and in here changing the camera to objects main cam 2, and then same thing, just another copy of these. Alt click and drag, and then just selecting these and changing the name to 3. I want to make sure here on the reflection that the motion blur is on and set to 0.4, which wasn't. So let me select these two and do the same thing. Motion blur on and 0.4. This is important. One thing that I almost forgot, and that's absolutely crucial that we don't forget, but it's really important, is don't forget to set up your output node. This would kind of resolve itself because it has these variables, but I'm going to set up for each one of these. I'm going to set up a proper output path. You should do the same, and after that we'll come back and see the final results all rendered up.